to solve another Leetcode problem. 2841, maximum sum of at most unique subarray. So from the title, we don't understand it. Yeah, basically we are going to calculate the maximum sum of an array. Yeah, now let's check what we are going to do. So a subarray of nums is almost unique if it contains at least m distinct elements. Yeah. So for this problem, we're gonna have a window size because we're gonna return the maximum sum out of all almost unique subarray of length k. Yeah. So what is the meaning? So definitely we are going to check a length of k. So for example, this is the length of k, and then we are going to check if there are gonna be at least m distinct elements. So inside of this window, it's gonna be 4 distinct elements. So the total sum gonna be 18. So that's going to be the final result. Yeah. So if we continue to slide the window, so the window size is going to be k, going to equal to 4. So all the numbers are unique. So the total sum going to be 17. Yeah. Now we're going to continue to slide the window. So the total sum is 18, and there are going to be 3 unique numbers. So this is also okay because we need to meet the condition of at least m distinct elements. So yeah, so in this way, everything should be okay. We just need to use a fixed sliding window, but while we are checking the result, we need to control inside the window. We're gonna have at least m unique elements. So what kind of data structure we're gonna use? Definitely it's gonna be a dictionary, because this is gonna be easier for us to solve the problem. Because according to dictionary, we can directly check how many unique elements. Yeah. So for the dictionary, I'm gonna define a counter and L pointer the result. So L pointer gonna be So I'm gonna prepare a result and total. Yeah. So L pointer gonna be 0, result gonna be 0, and total gonna be 0 for R n in enumerate. So currently I'm gonna use the sliding window. So for the total, it's going to be updated to this num. Now I'm going to check if r minus l plus 1 equal to the window size k. So I'm going to slide the window. So after that, definitely it's going to be l plus 1. Finally, I'm going to return the result. So what we're going to do inside the window. Yeah. First of all, we're going to update the final result, but we need to check the unique element. How can we check the unique element? We're going to use a counter. So d n gonna plus equal to 1. Yeah. So if the length of the dictionary is more than and equal to m, basically it means we're gonna have at least m unique elements, and we can update the final result. So it's gonna be the maximum of result with this total. Yeah. So currently everything should be okay, but how can we slide the window? So before we update this L plus equal to 1, we need to update the total first. So the total going to be minus equal to what's going to be the current value. So it's going to be the nums L. Yeah. At the same time, we need to update the dictionary. So the d nums L gonna minus equal to 1. So if d nums L equal to 0, it means if the counter equal to 0, definitely we need to pop the k out of the dictionary. So it's gonna be d dot pop with nums L. Yeah. Up to now everything should be okay, and let me just run it to check if it works. As you can see, it works. Now let me just submit it. Yeah, so this is a very good problem for checking the sliding window problem. As you can see, it's pretty fast, and the time complexity is O(n). Yeah, basically this is just a sliding window. It is a fixed sliding window, and the space complexity is O(n) as well, because we used a dictionary. We used a counter to solve the problem. Yeah, I think that's all about it. Thanks for